In this video, we're going to be looking at symmetry. And probably when I say that word, you have a definition, a loose definition that kind of pops up in your head. And we think about it being, two halves that are the same. And that's essentially what we're going to be working with in math as well. But we're actually going to be looking at three different types of symmetry. So we're going to be looking at symmetry with respect to the x-axis, symmetry with respect to the y-axis, and also symmetry with respect to the origin. So we're going to look at the definition for what each of those means. We're going to talk about what it means visually, and then we're going to use those to be able to determine whether some graphs have symmetry and what kinds. So a graph is said to be symmetric with respect to the x-axis if for every point AB on the graph, there is also a point A negative B on the graph. Visually, basically the x-axis acts as a mirror for the graph. So the way I like to think of it is if you could fold the graph in half on the x-axis and the two halves would match up, then the graph is symmetric with respect to the x-axis. On the flip side of that, a graph is said to be symmetric with respect to the y-axis if for every point AB on the graph, there is also a point negative AB on the graph. So instead of the B value flipping to the negative side, in this case, the A value becomes negative. And visually, we have that the y-axis acts as a mirror for the graph if the graph is symmetric with respect to the y-axis. I like to think of it as if I folded the graph on the y-axis, would the two halves line up? If the answer is yes, then it's symmetric with respect to the y-axis. And last but not least, a graph is said to be symmetric with respect to the origin if for every point AB on the graph, there is also a point negative A, negative B on the graph. And visually, what it looks like when it's symmetric with respect to the origin is that it looks the same upside down as it does right side up. So if you were to ask yourself, hey, if I flipped this graph upside down, would it still look the same? And the answer is yes, well then you know that the graph is symmetric with respect to the origin. Another way of thinking about that type of symmetry is if you could take one half of the graph and rotate it 180 degrees and set it down on top of the other half of the graph, then it would also be considered symmetric with respect to the origin. So whichever one of those visualizations make more sense to you is fine for you to use. So let's look at some examples here and determine what type of symmetry we have in each of these graphs. Now, keep in mind that you can have more than one type of symmetry. So let's start with our circle here, and let's look at first the symmetry with respect to the x-axis. If I were to draw a line on the x-axis and we were to pretend like that was a mirror, if we were to fold it, would this half of the graph match up with this half of the graph? And the answer is yes. Therefore, this is symmetric with respect to the x-axis. However, we can't stop there because remember, it is possible for a graph to have more than one type of symmetry. So now we need to check, okay, well, what about with respect to the y-axis? So again, if we were to draw a line on the y-axis, would this half of the graph match up with this half of the graph? And the answer is yes, it would. So this one is actually symmetric with respect to the y-axis as well. And then last but not least, let's think about it in terms of the origin. If I were to take this graph and flip it upside down, would it still look the same? And the answer is yes. You wouldn't be able to tell if it had been flipped upside down by anything other than maybe the numbers on the axes. So in this case, we have a graph that is symmetric with respect to the x-axis, the y-axis, and the origin. So let's look at our next example. So we'll start by talking about the x-axis. So if I were to draw a line on the x-axis, does the graph match up with itself? Well, no, clearly, in order for it to match up, there would have to be another piece of the graph down here somewhere, and that doesn't exist. So this graph is not symmetric with respect to x. What about y? Well, if we draw a line on the y-axis, does this half of the graph match up with this half of the graph? And the answer is yes, they are mirror images of one another, or if you were to fold it on the y-axis, they would sit on top of one another. So this one is symmetric with respect to the y-axis. And then the last one we're going to check for is it symmetric with respect to the origin? Well, if I were to flip this graph upside down, would it still look like a U? No, it would look like an upside down U. So for this particular graph, it is only symmetric with respect to the y-axis. In our next example, we start by thinking about if we were to fold it there, would these two halves match up? And clearly you can see they would not, because it would look like this, and that is not a mirror image, so it is not symmetric with respect to the x-axis. If we were to fold it on the y-axis, well, again, this piece would be over here and this piece would be way over there, so they would not match up. And if we were to flip it upside down, it wouldn't look like a U anymore. It would look like an upside down U or V, whichever one you think it looks more like. But that means that it's not symmetric with respect to the origin. So in this case, there is no symmetry for this particular graph. And I wanted to look at that one specifically because what's the difference between these two parabolas? Well, the difference is that this one has an axis of symmetry on the y-axis, whereas this one has an axis of symmetry over here. In other words, the two halves would be symmetric if we drew a line here, not on the y-axis. And that's the reason one is symmetric with respect to y, while the other one is not. And then last but not least, we have a sideways parabola. And if we were to draw a line on the x-axis, we can see that it would in fact fold up and the two halves would match. So it is symmetric with respect to the x-axis.